flow for this. So in this example, they're using flowers. The idea is you take, for example, Inception v3, which has lots of trained data already inside of it. As you can see, hundreds of thousands of GPU hours are inside of this, and retrain your model on this. So how it works, here's the Inception v3 model, for example. You have on one side, you get the input data, and at the end, it's what you're classifying. So for example, for the normal training, you start with a dog picture and say this is a dog here. And then with the back propagation, you calculate all the weights inside of this. Then you have a cat and also. And with the retraining, you just cut off the last layers and put your own images on this. So in the first part, there's something like with lines, curves, and so on. And the last line where you have, for example, the sweets, you retrain them. And therefore, I need here some sweets. We have some snack bear. I don't know if you know this upstairs. So I took my iPad, took some sweets around, and just take a video out of this, each one step by step. And then afterwards, I just split the video into images, and then said, okay, for example, I don't know, from 700 to 740, this is Snickers. And then I run a small script which classified all the images. As you can see on the left side, Mars. Yeah, oh yeah, it's advertising, so I think I have everyone. But I'm not selling this stuff, so don't worry. Okay, and at the end, after you've done the retraining and everything, you get a model out of this. So this is a TensorFlow model. And the problem is, I thought, how to get this into an iOS app. And therefore you have CoreML and CoreML tools, which converts a model into a CoreML model. So this is also new in CoreML 2. The box inside of it was the first version, which was announced last year. So they have Caffe and Keras, for example. And during the year, they also came up with TensorFlow. So I was sitting there and thought, okay, as you can see, it was in January when I did this image stuff. And in December, they had TensorFlow CoreML. So I was lucky for this. And there's a GitHub project available. Very important is the example with the Inception v3, because you have lots of operations inside of it which you have to get rid of and everything to get a real CoreML model out of this. And how is CoreML working? So you have the model file, ML model. You just drag and drop this in Xcode, have your CoreML, and then you have your app for this. And the cool thing is, Apple knows what devices they are selling, so there are not so many. So they also know, okay, you have a CoreML and a metal performance shader, which is connected directly to the GPU, for example, for image classification, or the accelerate for language processing. And also the vision thing is, you just throw in an image, and it realizes what it can do with this image, depending on the model itself. So I have a demo now, I hope. Okay, this one, yeah. Okay, this is using Inception v3, and when I click one of these images here, it just changes the other one, and then you get the name of it. So this is a lighter, this is a package, and as we saw on harmonica. And here is the code for this. So first of all, I have here the Inception v3 model, which no one can read. I don't know why, because it's not code. So you can see here in this part, you need an image 299 by 299, and you get a dictionary out of this, and with this you get the classification. And Xcode also generates the code for this. And this makes it really easy. So I just take here the model itself. Then I need a request for this with the completion handler. This is the result handler here, it's down. And what this does is just getting the request. It's looking if there's a request available in this class, and then print out the first 5 classification it's found, and change the value of the images, of the labels. And here's an action, so when I press one of these images, I change the one image of this and just add this image, so independent of the size, here, and then it calls the handler. Okay. And now I have trained my trained model. This is the Suite 003, because I tried it 3 times or so. And just run this again. It should come up here. And when I now click on Mars, nothing happens. Yeah, it takes some time. It's still a lighter. Okay. Then I take this one out. Okay. Yeah. Now we have 90% Mars and 2% bounty for some reasons. So this is image I took this morning with the real Mars bar. This one is just out of the internet. I just looked for KitKat and found it. And here I have Snickers. This is, I think it's from Wikipedia, this image. So, and as you can see, it's 39% Snickers and 25% Mars. So it worked. My training data itself wasn't really not so well, so I get also some notifications like you need more than 20 images. But now it's working. Okay. And let's go to the CoreML2 part. So there are videos available. I think if you're not doing iOS, these videos are also interesting for people who are interested into machine learning, because there are lots of cool stuff inside of it, and I just pick 3 examples out of this. So CoreML2 is smaller, faster, and customizable. First question is, why do we want to have a model on a mobile phone? So one thing is the privacy. You don't want to send your data somewhere. Speed is also something. If you don't send your data somewhere and stays on the machine, it's also faster. And if you don't send some data somewhere, you don't need a server. So this is also one thing. And it's available. So if you find a Snickers somewhere without Wi-Fi connection or internet, then you can recognize, okay, this is a Snickers, for example. But the problem is, these models, so for example, Inception v3 is nearly 100 megabyte big, and as you already told, don't want to have an app with this big size and so on. So therefore, they came up with the idea how to reduce the size of a model itself. And the factors of this is number of models. So when I run, for example, v3 to recognize, is this a package, is this a street sign or so? For the first classification, afterwards the Snickers, I have 2 models. So I will get nearly 200 megabyte. Then the number of weights for the calculation, it's the calculated model, and also the size of the weight. So here I have the Inception v3 model again. So every dot you can see, this is a weight, a calculated weight or calculated value on it with the back propagation, everything. And yeah, they came up with the idea. So with iOS 11, it's 1 year old now. They used 32-bit float values for this. Then they reduced the size just by using 16-bit values without losing the quality of this. And with the quantize thing, which Sergey already told, you're able now to shrink down your model. So the weight size gets reduced. So you have the possibility to use 8-bit, 4-bit, 3-bit, 2-bit, and 1-bit, for example. The problem with this at the moment is, if you want to shrink down this with the quantize thing, you need Mac OS 10.14. I'm lucky I have my old computer upstairs, so I just put a better version on it and was able to reduce the size. And therefore I have a demo. So here's the same code again, and as you can see we have model Q, which is, I just use with 8-bit. Maybe we should just look at the numbers again, and someone has to remember this. So Mars has 90%, Kit had 48, and Snicker 39. Can someone remember this? Okay. Oh, it's recorded. Never told me this. Surprise, surprise. So wait, this one, and this one. So I'm using now the Q thing. In this case 8-bit, and you have also a possibility with linear quantization. So this means you have your values from 0 to 1, and it just splits up. For example, when you're using 8-bit, you have 256 values just split up. And with the lookup table, you can also use this. So for example, if you have in the beginning and at the end only one value somewhere, then and more values between, so there's more the lookup between all these values. Okay, so 90 will be now 89, nearly the same as quality. This was 48, it's better. So this is the thing you also told, it's like sometimes it's getting better. Maybe my my training data are not so good and getting better now. That's what I was thinking about. This was 38 or something. It's getting, or 39. Yeah, it's still the same. So I've reduced the size. I'm using, which one I'm using? This up with the lookup table. It's 22 megabyte, and the first. Itself, the main thing, it's 87 megabytes. So I reduced it by factor 4, 3, something like this. Okay, yeah. And now I'm doing, where I am here, just 4-bit. 4-bit. Let's see. Okay, this was something 90, it's 39, so it's losing the quality on this. This is 63, it's getting better. And the Snickers itself, it's 44, it's also getting better. So it may depend on also on the images. So they have an example how to shrink down the size of it, and normally you should have some training data, some validation data for this, and then you can also compare the actual model with the smaller model, and then you get back something like, I don't know, in this example they are using it's 94%, so this means it's just losing a little bit of the quality. In this case, I don't know, maybe I found lucky pictures for this, so it's getting better. I don't know, should I try? We have some time, I can try number 3 bits. First, I have to put this in. Didn't expect it will get so good. So, oh yeah, and the size of the 4-bit was 10 megabyte, and with 3 megabytes I'm now at 8 megabytes. With 3-bit I'm at. Did I have deployed it? I just run it again to be sure. Okay, let's see. It's still Mars, but only 17%. Okay. Now it's a lion and Mars, so now it's getting worse, yeah. And this is now the Mars, and yeah, and you can see the values are not so very good now. Also, the first hit is very low, so this is also an indicator that your data are not so good at this point, yeah. Okay. Another thing is the numbers of models you are using. So, for example, I have the Inception v3 and my Suite model, and with COML2 you can combine them together, and then they try to figure out with the model and all the data to shrink this also down. So you have the possibility here to have 2 models in one. This will reduce also the size. Next point is to make it faster. When I just drag and drop the model inside of Xcode, it generates code. And this is, I just copied the code out of this, so you can see if available for iOS 12, then they are using a batch, running the classification or the prediction on a batch mode. So they parallelize this. Instead of step by step for when you have many models, you are able now to use it as a batch mode. So this makes it also faster. And the customizability, this is also interesting. So with iOS 11.2, they come up with custom layers. So you have, for example, you define your model with TensorFlow and come up with some crazy idea where you have need external code for this. So instead of waiting before someone else is implementing this, you can just take out this layer here between and implement this on your own. So this is a customer layer, and also customer models itself, because normally you need a multi-array as an input and output, and with the custom models itself you can use any data, int, string, for example. So this makes it customizable. Yeah, that's it. So takeaway was you can train your own model and use this. You need some data for this. CoreML, just drag and drop, call it easily, and CoreML2, smaller, faster, customizable. That's the point with CoreML2. And it's relatively new. And as I said, to do the quantization, you need the new Mac OS for it. It's cool, but it looks cool, the dark mode. Okay, yeah, that's it. Questions?
Some KitKat online for you, since you developed this.
Okay, thanks.
Any questions? No, not a single one. How many KitKats have you eaten while developing that?
I just put it in my backpack and it got damaged.
In a backpack, if you know what I mean.
A backpack in the end.
Exactly. Anybody else? No? Okay. Thank you again for an amazing talk.
Thanks.
Yeah, I think that's all for us today. So feel free to, if you would like to stay a bit longer, grab a beer. If you have beers or bottles like next to you, please bring them back, because otherwise somebody else would need to do that. And if you'd like to present something, please put like a small entry next to mine. Otherwise, it's like only one there. It's not going to work like that. Thank you again, and hopefully see you soon.